In this session, we're going to introduce the second kinds of subspace clustering methods called correlation-based methods. Essentially, for subspace clustering methods, the similarity measure can be based on distance or density, either. But for correlation-based methods, it is essentially based on advanced correlation models. For example, PCA, or we call principal component analysis. This approach, you probably can see from the picture on the right. You'll see, suppose we have two dimensions, x1 and x2, those points projected into both x1 and x2 with certain distribution. However, if we get another axis E, we probably can see, because all the points line up or cluster around axis E. So if we use axis E and its perpendicular axis, we probably will see, essentially using E axis, we will be able to represent the data. So that means we want to find a projection that captures the largest amount of variation in data. Then we can apply PCA to derive a set of new uncorrelated dimensions that essentially we get a two-dimensional data projected onto one dimension. We did dimensionality reduction. Then we can find clusters in the new space or its subspaces, but we find dimension in the lower dimensional space, finding clusters. Other correlation-based methods, including half transform or fractal dimensions, we're not going to introduce these. Interested people can read wiki or some textbooks. Here I give a little simple illustration of principal component analysis in a little detail. Suppose we have big N data points, data vectors, from small n dimensions. We want to find a k orthogonal vectors, that means principal components. Usually the k is much smaller than n. And then if these principal components can be best used to represent data, then this transformation will be very meaningful, because we can find in the much lower dimension, we can find clusters. So the first step is we can normalize input data. It means each attribute will fall within the same range. Then we are going to compute orthogonal, or we call linearly uncorrelated, or you can say perpendicular unit vectors. That means we want to find these k principal components. Then each input vector essentially is a linear combination of these k principal component vectors. Then we can sort these principal components based on the decreasing significance order or strength order. That means the stronger one will be ordered higher than the lower significance one. Okay. Then we can eliminate the weak components. That means those with very low variance, we can eliminate them. That means we use the strongest principal components to represent the data sets. It is possible to construct a good approximation of the original data. Then we can find the clusters just on those strongest principal components. This is principal component analysis. Of course, the detail how to compute it, we're not going to introduce here, because it will involve like a computing covariance matrix, compute their eigenvectors. It's a little too mathematical. If you want to know more, there are lots of textbooks you can read.